Our knowledge of Mars is extraordinarily detailed compared to the first observations made with telescopes over 400 years ago. There are dust storms post the discovery of methane in the Martian atmosphere that has made the most impact. This methane could be from geological activity, or it could be a byproduct of life.
Based on what we know from Mars Express and from other missions that have gone before, methane is a hot topic. So trying to understand the origin of the methane and where on the surface of Mars and when it's being produced and how it is destroyed is very important.
The ExoMars 2016 Trace Gas Orbiter will carry 2 instruments capable of studying the distribution of methane in the Martian atmosphere. And the CASIS imaging system will provide the next generation colour pictures of the surface to help identify where this methane is coming from. Its predecessor, the high-resolution stereo camera on Mars Express, helped scientists select the landing site for the NASA Mars Curiosity rover, which arrived in Gale Crater in 2012. ExoMars 2018 will later bring Europe's first rover to Mars, and combined with the ExoMars Trace Gas Orbiter will help us fill in the gaps in our knowledge, whether it's about electrical processes in the atmosphere today or the history of water on the planet.
There remains a lot of questions about the duration that liquid water was on the surface, for example. And I think these are the sorts of things that we have to go after to try to understand what was happening in the past. The other thing is, I think we need to understand a little bit better as well what is really the water inventory with depth. Because if you want to land people on there, they're going to need drinking water, and you don't want to carry it with you.
In the mid-1970s, NASA's 2 Viking spacecraft landed on Mars, specifically tasked to search for life. They couldn't provide conclusive evidence, but the joint European and Russian ExoMars program will be the first mission since then with this aim. ExoMars 2016 is a complex mission. It's a technology demonstrator, a way of relaying information between the lander, the orbiter and the Earth, and it's a science mission. The high-resolution camera, CASIS, acts as the orbiter's scientific eye. This is CASIS being tested at the University of Bern in Switzerland, where it was built. The camera is actually a telescope with a sophisticated detector that can provide colour and stereo images over a 9.5 kilometre wide strip.
We begin by pointing 10 degrees in front of the spacecraft as the spacecraft moves over the surface of Mars. Once we take our first image, we then use a mechanism to turn the telescope around by 180 degrees so that we're pointing 10 degrees backwards. And in this way, we can construct a stereo angle of about 20 degrees, allowing us to get the 3D topography of the surface. This technique allows us to get higher resolution because we can build the telescope for one specific direction.
CASIS will be able to examine recurring slope lineae on the surface of Mars at different times of the day over the planet's seasons. The lineae are the dark lines believed to be associated with liquid brine that increase in size during the Martian spring and summer and fade away during autumn and winter. Also on board the orbiter is the NOMAD instrument, built at the Belgian Institute for Space Aeronomy on the site of the Royal Observatory. NOMAD will be the first high-resolution instrument of its kind around Mars. It consists of 3 spectrometers, 2 working in the infrared and 1 in ultraviolet, and it can identify trace gases, such as methane, in the atmosphere.
They will be looking directly at the surface of Mars. That's what we call nadir observation. That's one kind of observations. The other kind of observations will be looking at the sun during sunsets and sunrises. And doing both kind of measurements, you can derive more information on the atmosphere of Mars.
The European NOMAD and CASIS instruments are joined on the orbiter by 2 Russian instruments, the ACS Atmospheric Chemistry Suite and the Fine Resolution Epithermal Neutron Detector, FRIEND, which will map water ice deposits, both on the surface and up to a metre deep, 10 times better than existing measurements. The Schiaparelli lander, seen here in a clean room at Thales Alenia Space, is primarily for demonstrating landing technologies, but it also carries a descent camera, Decker, and a small science payload. A suite of sensors called DREAMS will characterise the dust and Martian environment, and the Amelia package will collect the valuable entry and descent information. The presence of methane in Mars's atmosphere offers intriguing possibilities. It could result from geological hydrothermal reactions in the planet's mantle, or it may be from simple life forms like microbes. Whatever the origin, Mars is no longer a dead, red, dusty planet, as it's much more dynamic than previously thought. But the information gathered by the ExoMars Trace Gas Orbiter and the Schiaparelli lander will not only further our understanding of the planet, it will also help the ExoMars 2018 mission, which will include the first European rover on Mars.
Ну-ка на видео меня сними, что видео у тебя хорошее. В полет пойдем? Или как?
Сереж, нам нужно вернуться.
Slightly earlier. I'm Daniel Skuka. I'm the Senior Editor for Spacecraft Operations here at the European Space Agency, and today we are taking you on a tour inside the main control room to meet the ExoMars mission operations team working here on the ExoMars mission, which has just been launched today. Let's do a quick walkthrough into the main control room. This is actually an old tradition here at ESA where on the various doors of the main control room, there's just one here, but on the door around the other side we've got quite a few of the other teams who actually post notices to the newly launched mission that we're going into a restricted area. Let's see what, let's make sure that the security badge works, and I think it does. Okay, we're walking through the main control room here at ESOC in Darmstadt, Germany. What you're seeing is the mission control team, an actual team of teams, which right now are working very hard on the ExoMars mission. The next big milestone that we're waiting for is confirmation of the fourth burn, which should be coming in a couple hours from now. And after that, the really big news will be receipt of signals, the AOS, acquisition of signal from space. Hey, Sylvia! Let me see if I can do a selfie here with Sylvia. We'll just swing around. Will she fit? Yes, she will. This is Sylvia Sangiorgi. She is the Deputy Spacecraft Operations Manager working on ExoMars. How's it going?
Hi everybody, it's going okay. It's tense waiting to the first acquisition. Finally tonight we are getting some news from the Russian. They sounds good news, but we want to see the signal tonight.
Good stuff. Now tell me, what are some of the things you're doing today as the Deputy Spacecraft Operations Manager?
Okay, here in the main control room I'm responsible for the front rows. So you can see it's all the guys sitting here. We have several engineers. Every engineer is responsible for one subsystem, one spacecraft subsystem, and we are the first line to the spacecraft. So when the signal arrives, we are the first one checking the data of the spacecraft, and also we are the one commanding, sending the commands to change operational mode or to achieve what needs to be achieved by the spacecraft. So,
Sylvia, tell us a little bit about some of the training you guys have done. Now, I think you've had something like more than 20 pretty intensive training sessions to actually simulate getting ready for today's launch.
That's correct, yes. So we have the SIM officer, so there are experts on...
There's our SIM officer?
On the simulator, so we have the software that simulates the spacecraft data, and they can set it up to have a nominal scenario, so just to let us see how the things will go in nominal operation, but also they can inject a lot of values, so they can see how we react, and this is of course from the technical point of view, but it's a lot of training also from the psychological point of view and from the team working point of view, because you get people coming in ESOC itself already. We are coming from several countries. So
where are you from?
I'm from Italy.
Okay.
I think you can hear from the accent. And okay, several different language, different culture, and here we have to take very critical and time in a short time decision, and where everybody has to participate with this piece of information, and then we have to put together the information and react on it, and this needs a lot of training. Yes,
right,
so that's what we do. And then also we have the support from industry for the LEOP. That's such a critical phase. They are sitting in a room here, but also there the communication has to be built with the training.
Okay, now Sylvia, the critical question that we all want to ask you: have you seen the movie The Martian?
Of course, I've seen The Martian. We went all together. It was a big team building actually event for the full team. We were waiting for it for a few months, and then we finally went. We booked the full room at the theater.
Oh, that's cool.
Watched it all together.
Good stuff. Okay, well, listen, we'll let you get back to your work here today. And of course, today, just to confirm, it's not a simulation anymore. This is the real thing, isn't it?
I know. Yes, it feels real. So.
It feels real. Okay,
Yeah.
good luck and best wishes for a smooth AOS.
Yes.
Okay. We're going to carry on over here, and Sylvia was just mentioning about our simulations, and
Yes.
we'll just chat with Jamie here for a minute. Jamie, you have been deeply involved in the simulations. Indeed, you were actually controlling you were the Sims officer. What are some of the evil things you do to the team to get them to be able to react quickly?
My goodness. Well, there's lots of things that you can do. Not receiving first AOS, for instance, is one of them. Not deploying the solar arrays, another one. I mean, there's lots and lots of evilness that we come up with. We pride ourselves in being quite creative in that regard. But yeah, we also go to things like doing fake fire alarms. We take key people out of the MCR at key moments. So it's good fun. I have to say the team took it in good spirit, and they've allowed me to join them today. Because obviously running all those simulations, we got pretty handy using the simulator itself. So in case we need to do any last-minute tests during the LEOP itself, we're on hand to set these tests up for them and help them in any way that we can. So, yeah.
Right.
But if it all goes well, hopefully I just sit back and enjoy the food.
Good stuff.
We'll see.
Now, could you give us a ranking on a scale of, say, 1 to 10? How ready is this team to actually go to space today?
The team is at an 11, and unfortunately there's no way back now. We're launched, so we have to see what comes. At the moment it's pretty tense because we have to wait for this fourth burn to occur, and then we have to wait for the first acquisition of signal. That's when we can take control and can rectify any problems that we might see. But as I say, hopefully it will go smoothly. Hopefully the training was worse than reality.
Than reality. Good stuff. Thank you very much, Jimmy. Good, great. Okay, we'll just move along here to the front row a little bit, and here's Jake. Jake, have you got a minute? Jake, can I jump in? Yeah. This is Jacob. Now, Jake, actually, you're a kind of a transplant, right? You normally work on the Rosetta mission team. Is that correct?
That's correct. I've fully transitioned over now, so.
Okay, but you're working on ExoMars for a while.
True.
Jake, could you give us a sort of an indication of what is some of the information you guys see here? Now, of course, we're not in contact with the spacecraft right now, but what will you see later on?
Certainly. So we have multiple displays that we can use. One of kind of the typical ones is these ones that list just a bunch of data with a bunch of times. So here we can see specific telemetry items, so information items. You know, is this unit off? Is it on? What current do we have? What voltage? And then we have also a few nicer things. We can make plots, like this one here, for example. And we can monitor pressure trends or temperatures or where the spacecraft is pointing and how it's deviating. And then maybe lastly, we have plots like this, which highlight in color things that go wrong right away. So you can see a lot of red there, but it's expected for the last time we had the spacecraft. So we have a lot of tools like this that help us visualize.
Now, Jake, you are responsible for AOCS, Attitude Orbit Control Systems. As soon as we have AOS, and as soon as we have contact with the spacecraft, what are some of the critical points you're going to be looking at first?
Okay, so it's actually kind of fun on the AOCS side because we get to do a lot of things in that first shift. So we get the spacecraft in kind of like a safe spin where it's rotating and making sure that the arrays are getting illuminated. And so the first thing we want to do is, okay, after checking everything out, we want to switch on our star trackers, which are cameras that look at the stars, and based on which stars they see, they figure out where we're pointing. Once we do that, we can actually transition to a more stable, controlled mode where we're not spinning anymore. And from there on in, we can do a number of other checks. Eventually, the goal is to switch on our reaction wheels, so we're not controlling using thrusters anymore, but using our reaction wheels. And once that happens, we can go to an even more stable mode, and that's the end goal from the AOCS side.
Jake, thank you very much for taking some time to share with us today, and best wishes for a smooth AOS.
Thank you very much.
Thanks. Okay, we're just going to carry on over here and see if we can talk with some of our colleagues on the ground operations team, and I think we've got Daniel Fear. Daniel, have you got a minute?
Daniel.
Yeah, good first name. Let's see if we could, thank you very much, make ourselves comfortable here. Now, this is Daniel Fear. He is working on the ground operations team. Daniel, could you give us an overview very roughly as to what you guys do here in this particular set of consoles?
Yeah, for sure. So from this set of console, the role of the OM is basically to control all the ground segments, which is, let's say, all the things that are between the spacecraft and the flight control team working on all those consoles that you see everywhere. That includes the comms line, and that includes also all the ground stations.
Now, as I understand it, you've got a pretty critical job today. It's you guys here in these consoles. You actually see the first signal that comes from ExoMars when we get AOS acquisition of signal.
Yeah, that's pretty cool. That's always a good privilege for the OMs because we are the first one to catch the signal, hopefully. And today it's a bit of a special event because this launch we have seen already 6 hours ago, and we have another nearly 6 hours to wait until first AOS, which is quite abnormal. Normally we have separation and AOS within the first hour. So it's quite a relaxed environment at the moment, but it will certainly not be in 5 hours from now.
Right. Now, Daniel, give us a quick rundown. What happens if your ground station doesn't see the signal? What are some of the immediate actions you can take to handle that?
Well, we first go to the nominal case. If the launcher behaves perfectly nominally, we have separation from the launcher. Oh, here we go. We have separation, and the spacecraft is exactly at the place where we expect it. Which means that from the ground station, we will point our antenna to the place where the spacecraft is supposed to be and catch the signal immediately. If this has not taken place as expected and the spacecraft is a little bit outside of the antenna beam, then we have our first approach is very simple. We have those big antennas, and on the first acquisition antennas that we use, like in Malindi or Maspalomas in Kourou today, we have also a very small beam attached to the main one, and that small antenna has a very wide beam. And that very wide beam covers a much bigger part of the sky. And with a launcher like the Proton here, we should be able to catch the signal immediately within the large beam of the small antenna. If this is not enough, if we're really in a contingency scenario, then we can go one step further and start searching. So this is a kind of spiral pattern that we do across the sky with the small and the big antennas to try to find where the spacecraft signal is.
Good stuff. And it's basically, it's your team here, it's sitting at these consoles who are responsible for making all this happen a little bit later on today.
Yes, for sure. Except the very first ground station, which is Malindi. This station is actually an ESA antenna, but operated by Italian Space Agency on their territory in Kenya. This is local operation from there. All the other ground stations that we will be using today are direct controlled by the OM team from this console here.
Good stuff, Daniel. Thank you very much.
You're welcome.
Good luck with AOS.
Thank you.
Okay, we'll come on over here and we'll do one final quick chat. We'll just see if the flight director has a moment free, and we'll just wait. I don't want to jump right in and interrupt when he's chatting. And we're sitting here at the flight operation director's console, and this is pretty much the main control center where everything happens. Everything is visible. All the data, all the information coming from the satellite, and all the systems on ground. I'll just switch the camera so you can see what we're looking at. Okay. Yeah. No problem. And Deputy Flight Director Misha Schmidt, do you have a minute? That's
sure.
The key question. Could you chat with us a little bit about what's going on with the mission right now?
Well, what is going on with the mission right now? We have done our part when we were following the launch preparations while the spacecraft was still on top of the rocket in Baikonur, and we had liftoff a couple of hours ago. And what we do now is we follow actually what the control team of the Russian launcher is reporting to us. We don't have any visibility; we're on their hands, and on predefined times they inform us about the performance of the upper stage. And the upper stage has a couple of burns which actually spiral us into a final trajectory towards Mars. Okay. So all we can do now is waiting until the time, the predefined time is over, and we get our acquisition of signal from the spacecraft.
You make it sound very, very simple. I suspect it's not quite as simple as you make it sound. How long has the training been going on to get ready for today?
For spacecraft operations, so the training is it's difficult to answer because there's a training period. Actually, the team is being trained on the console with procedures, with the simulator, with the mission control system all in place already, and everything falls together. Yeah, the puzzle pieces of the puzzle fall together to build a whole picture. And this is an intensive training period, which starts typically 3 to 4 months before the launch. And we start with a nominal scenario. We have the spacecraft. Everything is going okay. There's still enough things to be clarified. And then the simulations officer, which are the masters of the ceremony for the training, get more and more nastier. So they actually inject failures and things like that. So that is the story since 3 or 4 months. And but basically, the learning of how the spacecraft behaves, what the spacecraft is, continues or starts much earlier for the team. And so typically, if you work as a spacecraft operation engineer for a mission, you start maybe 4 years, 3 years before launch, and you follow the process while the spacecraft is being integrated and being developed, being manufactured. And typically what we do here for planetary missions, so the mission here is planetary missions, of course we go to Mars, right? But also for astronomy missions, these are prototypes. Yeah? So it's not like you jump from one mission to the other, it's exactly the same. Yeah? We have standardized as much as possible the onboard functionality, but also the on-ground functionality. So we don't start from scratch all the time. So we have a kernel for a control software, a satellite control software, but you have to build your stuff around, which is dedicated and typical for this prototype. And for most of the cases, it's just this one prototype is launched. Yeah? Right. And it's very specialized.
Right. Final question. For you personally, what was the most interesting aspect of getting ready for the ExoMars launch today?
The most interesting aspect, which is the waiting period now, that is something which is not very, let's say, we don't do very often. So typically, you have a launch of a spacecraft, which is either a direct injection or a injection into an orbit around the Earth. You have liftoff, and 20 minutes after liftoff, you get acquisition of signal. And today is special. We have this waiting period of more than 10 hours. We actually we are waiting, and we are in the hands of the people who control the upper stage, or the SPRI's upper stage of the Proton. And this is for me something we don't have too often. This is something new for me. That's something special, which makes this day a little bit special. But for me, it's also special that for me, it's the first time I'm on a planetary mission. I'm going to Mars, so this is also an interesting aspect I never had before.
Misha, thank you very much, and good luck with going to Mars, and good luck with the smooth AOS acquisition of signal in just a few hours from now.
Thank you very much.
Thanks. Okay, we'll switch the camera around, and we'll just finish doing our walk through the main control room here. I think you've seen pretty much all the positions and seen what most of the guys and gals are doing here. We'll finish up with a final sweep over the main control room. And that's pretty much it from us today. Thank you very much for watching our Periscope, and we'll make sure this one's available in Twitter for replay afterwards. And please do follow us via Twitter, and look for the restart of the web broadcast, the live stream, which will be this evening, and you can actually follow live the AOS right from the European Space Agency's Mission Control Center in Darmstadt, Germany.
Subscribe now to go deeper into space.